All right, so last time we left off talking about, well, this was the next thing that we were going to talk about, was the using positive and negative exponents. And so that's where we're going to be. That's where we'll start on today. Can you guys hear that? Is that fan really loud? There's, for some reason, my computer just kicked in with a loud fan on it. And somebody tell me if that's really loud for you. Are you having a hard time hearing me?
No.
You can hear me fine?
Yes.
Okay. All right, well, let's get going then. So we probably won't go through all of these, but we'll do a few of them, and then you guys can go back through and decide, you know, I mean, maybe try some other ones on your own. So I want to work on maybe doing this one right here, where we're simplifying this. So let's start by just going through what do you think would be a good place to start when we're doing these properties of exponents? So on this one here, can you see where my cursor's at? Hello? Anybody there? Let's just had something. We'll call this 37C, maybe. It'll be a little bit easier to talk about this way. So on this one, I would probably start by distributing the exponent that's on the outside through. And so when you do that, we have to work it up here a little bit. So we'll have 4 to the second power, and then x to the 6th power, because when you have a power raised to a power, you multiply those, over 3 to the second power, and then y to the negative 2 power. And remember, one thing that seems to get forgotten about on these type of problems is that people forget to give the power to those whole numbers out in front. Okay, so there's one of our factors that we have here. And then the other one, if we distribute that negative 2 through, you could do that, or you could flip it and make it so it's not a negative 2 anymore. And I tend to like that better, because when people see 3 to the negative 2 power, it kind of, it looks a little bit weird. So I'm going to start by just flipping everything that's inside. And so you leave it just like it is. So we'll have 3 to the x, or sorry, 3x to the negative 1 power, and then y to the negative 2 power. So those powers are staying negative. Those are not changing. The one that's changing is the one that's on the outside, because we flipped everything that was inside. And so then when we distribute that through now, that'll give us 3 to the second power, x to the negative 2, over y to the negative 4. I don't know why it's doing that. And then our other one, it says this. All right, so then when we're trying to multiply these together, I'm going to just, figure these out here. So I've got 16 x to the 6th. I'm just going to write it as one big fraction now, times 9 to the negative 2, and then 3 squared is 9, And then I've got y to the negative 2, so it's unhappy down there. I probably should have just switched that other one too. Let me go back up there and maybe just isn't it doing it? It's really weird. Oh my gosh. Okay. Let's see if I can undo that. All right, so I'm going to just write this down here. Sorry, this one's so much more sensitive than what I use in our classroom. So this y to the negative 2 and then y to the negative 4 is on the bottom. But then we want to switch everything and make sure that all of our negatives get switched, because we want to make sure that our answers are only using positive exponents. And another thing that I can see that is happening here is that I've got a 9 on the bottom that can divide out with that 9 on the top. So we can get rid of those. And so in my next line, then down here, I'll have 16x to the 6th. I'm going to move my y to the negative 2 upstairs, so it's y squared, and the y to the negative 4 upstairs, so it's y to the 4th. And then this x to the negative 2 needs to go downstairs. And then the last thing I need to do is just get my y's together and my x's together. So when we have things connected by division, remember we subtract those exponents. So I'll have 16, and then there's 4 more x's on top than there is on bottom, so x to the 4th. And then y squared times y to the 4th would be our y to the 6th. We add those when it's connected by multiplication. And so that's how we can get to that answer there. All right, so similarly, I'm going to look at this one, we'll call it D, part D on this. Because we need to make sure that you know how to work with exponents that have fractions in them as well. So, still the same idea that we had before, where we had to use, you know, if it's a negative exponent, it's still going to flip upstairs. And so I'm going to do that first. So I'm going to take all of this, and it's going to go upstairs so that all of my exponents are positive. So I have x to the 2/3 times x to the 1/2 times x to the 1/7. But now these are all connected by multiplication, so remember that that means I'm going to need to add those together, and in order to add those together I need a common denominator. Right? What would our common denominator be with all of these? You guys just don't want to talk today, do you? I fixed it even so that you could hear what the people were saying. But it looks like to me that 42 would be a common denominator we could deal with, because we know 2 times 3 times 7 gives us 42, so we could use that. All right. And so I'm going to just put it like this. And so when I'm thinking of this, right, 3 is what I have on the bottom, but then I change it to 42. So 3 times what gives me 42? Well, 3 times 14. So that means that I'll need to times the top number by 14 also. So I get 28. And then here, I'll need to so 2 times what gives me 42? 21, so I'll times the top by 21. And then 7 times what gives me 42? 7 times 6, so I'll times the top by 6. And now I just need to add those all of those numerators together. So I'll have x to the, let's see, what do we get here? That's 27 plus 28, so that gives us 56 over 42. Oh my goodness. Right. All right, so just make sure, you're just using those same rules that we have been using, but now it's just with some, let's see, what did I do there? 20, yeah. I'm 55, sorry. Looks really weird. All right. So, let's keep going on this then. Is there any questions that you have so far on these, or ones that you found on your homework that you want to look through? All right, hopefully this thing will cooperate with us. I don't know, it keeps wigging out a little bit here. All right, we've done a lot of these with plugging the number in, so I'm not going to, work this one through maybe, but just remember you're just putting 7 in place of x. 7 plus 2 is 9, and then the square root of 9 is 3. So that's what it's asking you to do there. Although it does say to determine the domain of this function, and that's not something that you're going to be tested on, is the domain of that. So, but let's go down here to simplifying some of these radical expressions, and I want to focus mostly on this one here. We'll call it B, right? So remember when we have this number out in the front, right, that's 64, that we're going to just do a little factor tree with that, right? So we know 8 times 8 is 64, and then 8 times, and so all of those break down to be 2's, right? All right, so now, but notice that this is a 5th root, right? So be careful on that with the test. Make sure you notice what kind of root is being shown there. So I'm going to rewrite this out again. So I've got the 5th root of 2 times 2 times 2 times 2 times 2 times 2. There's 6 of them. And then, if you want to write those all out, you can, but I'm not going to write all of those out. I'm going to take the shortcut on this when I'm doing these. All right, so remember that we need groups of 5 in order for it to come out, for them to be able to come out. So we'll take these 5 get to come out, and that leaves a 2 still inside, right? So I've got a 2 on the outside, and then a 5th root of 2 on the inside. And now I'll do my variables. So when we're doing the x to the 15th, remember you're thinking this, you're using the index, the number that is, the type of root that it is, to divide by. So we're saying, how many times will 5 divide into 15, right? And so that will go in 3 times. So I've got x to the 3rd that's on the outside, and there's no remaining x's. With y, 5 will divide into 8 one time, so I've just got a y out here, but then there's 3 y's still left over inside, so y to the 3rd. And then with my z, right, how many times will 5 go into 12? Will go in twice, so I'll have z to the 2nd power, and then that will leave me with 2 inside. All right, so be careful if this is not a square root. Remember, if it's a 3rd root, you're taking them out in groups of 3. If it's a 4th root, take them out in groups of 4, and so on. Okay. There questions on those yet? Please make sure to speak up. Let us know your questions, because if you have a question, somebody else is going to have probably that same question. All right, let's talk about solving radical equations now. So remember that we said when we're solving these radical equations, we need to get the square root by itself on one side of the equal sign. And so that is the case here, but look over here, right? We have this plus 2 that we'd have to move over first before we could do anything with that, right? But since this is by itself, now we can take, and the way we undo square rooting something is we square it. So we'll square both sides. And so when we do that, the square root and the square undo each other, and so on this side we're just left with 9 plus x. But here, right, we have x plus 2 all squared, which remember is x plus 3 times x plus 3. So you're really going to have to do a FOIL thing here, right, in order to get this side figured out. So let's go ahead and FOIL that through. So x times x is x squared, and then plus 3x, plus another 3x, and then plus 9. Right? And then if we keep going from here, right, we notice that we have an x squared. So that means that we're going to have to do some factoring in order to try and solve this. So let's first combine some like terms together there. So really I have 9 plus x equals x squared plus 6x plus 9. And then I need to put one side equal to 0 and have everything on the other side. So I'm going to choose to minus my 9 over and minus my x over. Right, so then that's going to give me 0 on this side, which is what I wanted, equals x squared plus 5x. And then from here, we look to see if we can solve this by factoring. And you can. It's a little bit different because we don't have that third term here. But remember that whenever you're doing factoring, you always want to look to see if there's a greatest common factor that can come out. And on this one, there is an x that we can factor out, and that will leave us x plus 5. All right. Then what do we do from here to figure out what x is? Because remember, we're trying to solve for x. Does anybody have an idea? Willing to speak up? I feel like I'm just talking to myself. Maybe you guys aren't in a place where you can talk. So we set both parts equal to 0, so we have x equals 0, and then x plus 5 equals 0. All right, so this one's done. So x equals 0 would be one of my solutions. And then I could subtract my 5 over, and x equals negative 5. And the ones that we've done so far didn't involve this where we had to, figure out like squaring this and then being able to factor it out. Ones that we've been doing really only came up with one solution. And on these, sometimes when we end up with two solutions, one of them doesn't work out. And so it's always a good idea to check these. But let's see, if we had something like this next one on there, well, this is going to give us, let's try this. So if we subtract that 2 over, right, and I'm just going to say, let's just say this is a square root. It showed a third root, but we didn't talk about solving anything with third roots, which isn't going to show up on the final, so you don't have to worry about that. It would only be something with the square root. So then we'd have the square root of x minus 5 equals negative 1, and then we would square both sides. So that would leave us with x minus 5 equals 1, and add our 5 over. So x equals 6 would be our answer on that. So it might be a little bit more like this, but I do want to make sure that you remember whenever you're trying to solve quadratics, you got to get everything over on one side and put the other side equal to 0. So this is a good one to make sure you know for maybe some other types of questions. All right, any questions there? All right, let's move on to complex numbers. Remember, these are our imaginary numbers, and they're really similar when we're working with them. I mean, if we pretend that I is, an x, just any other variable, we're really combining things together the same way. The only other thing that you need to keep in mind and that you need to make sure that you have memorized is that the square root of negative 1 is I, and that I squared is negative 1. So when we combine these together, we can combine the whole number parts together. So 5 plus 2 gives me 7, and then negative 6 minus 1 gives me negative 7i. And so that's all we can do with that one, right? Just combining those like terms together. However, if we have something like this, then we're actually multiplying these together. So you're still foiling them the same way that we have done with other types of variables. So let's start there. So 6 times 3 is 18. And then 3 times I is 3i. And negative 4i times 6 is minus 24i. And then negative 4i times I is negative 4i squared. Right. Now we can see that we have some like terms we can combine together. So let's do that. So that will give me negative 21i in the middle. But here, remember that our I squared equals negative 1. So we're really saying negative 4 times negative 1. We're taking that I squared out and replacing it with a negative 1. And so that's really a positive 4. And so then I can combine that together with my 18, because now those are like terms. And so I'll get 22 and then minus 21i. Right? And make sure you're putting it in that form, the a plus bi. Right? All right. Now, and you can try, some of these, like maybe this one or this one on your own. Just remember that on this one you're doing 5 minus I times 5 minus I. So it's still foiling that you're doing there. Okay? So I'll let you guys work on those, use it for a little bit of extra practice on some of those. All right, so the next thing on here is the square root property. So remember, when we're trying to undo something that is all squared, we can take the square root of both sides to be able to solve that. So some of the questions that you come across might be easiest to solve using this square root property. So if I take the square root of both sides, right, the square root and the square undo each other, leaves me with x plus 2 equals, and don't forget your plus or minus the square root of 18. But then remember, 18 can simplify, and you need to make sure that you have it simplified as much as you can. And so we get 3 times 3 times 2, right? So there's a pair of 3's, right? So this couple gets to go out, but the 2 is stuck inside still. So if I rewrite this, I have x plus 2 equals, and make sure your plus or minus still stays in front of this when we simplify it. Okay, so it's plus or minus 3 square root of 2. Right. And now we need to move that 2 over to get x by itself. So if I subtract 2 over, then remember I put that in front of the plus or minus sign. So I get x equals negative 2 plus or minus 3 square root of 2. And then that would be your answer. Okay. And remember, this means these are two different solutions. 2 plus 3 square root of 2, negative, or sorry, I didn't say negative 2 before, negative 2 plus 3 square root of 2, or negative 2 minus 3 square root of 2. And then, so the next thing, and again, I'll leave that one for you to do. Remember, I gave you the key too, so you can look up some of these, make sure that you're doing them correctly. But on this one, it's saying use completing the square method to solve this. And I want to make sure that it's clear, because I know it was seemed a little bit confusing for some people when we use the square, completing the square to write something in vertex form, and when we use to solve using completing the square. So on this one, we're trying to solve, right, using completing the square. So the first thing that we'd want to do is make sure our constant term was moved over to the other side of the equal sign, which one this one is already, right? On this one, you'd need to start by subtracting 7 over to get it to that side, okay? And so then I'm going to just write in my blank. So I have x squared plus 6x plus blank equals 1 plus blank, right? So we're adding on both of these, because whatever we do to one side of the equation, we have to do to the other side of the equation. So that's why I'm adding both of those. And then to do completing the square, we find half of the middle term, which is 3, right? And then I square it, and so that gives me 9. So 9 is what I'm putting into my blanks. So 9 here and 9 here. And I'm doing this because I just made this into a perfect square trinomial, so it will factor to be something like this one above us. So then we can use the square root property to solve it. All right, so when I factor this, I'll just take time to just factor it just to make sure everybody sees what's happening here. So x times x gives me x squared. What times what is 9? That adds to be 6. Well, that's positive 3 and positive 3. Right, so it's always going to be whatever half of that middle term is. That's always going to be our numbers that are in there. But then really, it could be written as x plus 3 all squared equals 10. And then we'll do the same thing that we did above there, where we'll take the square root of both sides. Right? And if we try and break down 10 like we did 18 up here, it only breaks down to be 2 times 5. So there's nothing that gets to come out of that square root. So we'll think about that. So now we just have x plus 3 equals plus or minus the square root of 10. Right, make sure you remember that plus or minus. And then the last step is to subtract the 3 over, so that will give us x equals negative 3 plus or minus the square root of 10. And that would be our answer here. Well, let's talk about this, because on the test it seemed like some students were still having a hard time with, how do I do completing the square if that leading coefficient isn't 1? All right, so let's take some of the steps here and make sure you see this. So just like we did before, or what I said to do over here, is we got to get that constant term to the other side first. So that will give me 2x squared minus 4x, right, equals negative 7. And now you can put in your blanks. So I'm going to do this in a different color so just to make sure it's really clear. All right, so, but before we can actually put in the blanks, yes, let me do this first. We need to divide the 2, right? We have to have this leading coefficient to be a 1. And so to get that to be a 1, I'll take a 2 out of that. So that will give me 2 parenthesis x squared minus 2x. Right? And then on this next, so once I've done that, now I can put in my blanks. It might be best for you to wait to do that like I'm doing here, just to make sure it's clear when you need to do that. Because now you're finding half of -2, not half of -4, which was the common mistake that I saw happening here, right? You've got to get this, so the leading coefficient here is 1, and once you do that, now you can fill in the blanks. So half of that middle term is -1, and -1 all squared is just 1. So I'll put 1 in both of my blanks. All right. And so here, this is a perfect square trinomial now, which ends up being, so we've got the 2 on the outside, and then x minus 1 all squared, right, because this factors to be x minus 1 times x minus 1, and then that equals -6. Okay. And then to solve it from here, remember we need to have that part that's all squared by itself, because we would take the square root of that. So let's divide both sides by 2 here. So that gives me x minus 1 all squared equals -3. And maybe I'll move it over here a little bit so we can see it a little bit better. All right, so now we can take the square root of both sides. And when I do that, right, I'm left with x minus 1 equals plus or minus the square root of -3. So I've got this negative inside the square root, so that's telling me that I'm going to have some imaginary numbers there that I need to deal with, right? So if I'm thinking about this, right, the square root of -3 is the same thing as the square root of -1 times 3. And then we said the square root of -1, right, we said that above here, so I should have just written it down again, is I. So that's what we're going to be looking at here. So this is really going to say, so we've got x minus 1 equals plus or minus, right, that I square root of 3. And notice that all of that stuff stays on the right side of the plus or minus sign. Don't put that I out in front of it. The only thing that's going to go in front of it is whatever we move over from the left side. All right, so I can add 1 over. So that will give me x equals 1 plus or minus I square root of 3. And that's how you can read that answer. All right, I know that was kind of a lot in there, and there was a lot of different, I don't know, there are questions that you have that I can answer on this, because that tends to be something that some were struggling with, or maybe not quite clear on completely.
I have a question.
Yeah.
So when you're getting the second blank, when is it that you multiply by the outside term?
Oh my word, you totally caught what I totally made a mistake there. You are right. Since this 2 is on the outside there, right, we were doing 2 times 1. So I should have added 2 to this side. Thank you so much for catching that. You were like, wait a minute, Becky, I thought that should have been a 2. And you were right, right? So this should be a 2. So when there's a number on the outside there, we multiply it through to this one. And so we get a 2 there. And so then that gives us a negative 5 over 2, which won't simplify as nicely, but still you're going to end up taking those same kind of steps there to get this, but then it's going to have the fraction on it, you know, to use that fraction instead with it there. But the stuff on the test is going to work out nicely, so you won't have like weird fractions and stuff to use in there. So it would be more like what I did there, but I did make that mistake, and it should have been a 2 that I added to both, or to this side, right? Because I have to do 2 times 1 there. Thank you, Melissa, for catching that. So if you look back at your the review that I gave you, it should have that worked out there with the fractions and stuff like that on it. Okay. All right, what about the quadratic formula, right? So make sure that you have the quadratic formula memorized, because that's definitely something you're going to need to know for this test. So remember, that says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And so let's go ahead and make sure it's in descending order, which it is, so I can see that this is my A, this is my B, and this is my C. If it wasn't in descending order, I'd need to switch it so that it was, to figure out what my A, B, and C are. And also I need to have 0, right? It needs to be equal to 0 on the other side. So make sure everything's moved over to one side and in descending order. All right, and then on this one, a lot of it is just making sure, you know, it's saying that we were going to round our answer. We're going to give the exact answer, but then round our answer to the nearest tenth. All right, so let's look at this. So if I have x equals negative 9 plus or minus the square root of 9 squared, which is 81, minus 4 times a, which is 2, times c, which is 8, all over, right? And make sure you notice, it's not just the square, it's not over just the square root part, it's over everything. You're dividing everything by 2 times 2. Okay? And then let's kind of do some simplifying here. Alright, so let's see, what do we get inside there? So we've got 16 times 4, which is 64, and so 81 minus 64 gives us 17, and then all over 4. Alright, double check me, make sure, did I do that right? Alright. Alright, and then from here, right, you could just put this into your calculator just from this point. So if we have, so our exact answer is x equals negative 9 plus the square root of 17 over 4. Right, and then I'll figure out the approximation for that. And my other answer, the exact answer is negative 9 plus or sorry, minus there. All right, square root of 17 all over 4. All right, so you guys do you know how to figure those out on your calculator? Make sure if you have any question about how to do that. Alright, so if I put it in my calculator correctly, I've got a negative 1.2, around to the nearest tenth. Speak up if you guys got something different than that. And then the square root of 17. And then I got a negative 3.3 for those solutions. Right, so if it asks for exact, solutions, this would be the exact. It already has your 2 in there, and you can just keep it written as plus or minus on the test, and then these are our 2 approximated answers for it. Okay. And then similar things are going to happen on that other one, so I'll leave that one for you guys to work through if you have any, want to have a little bit more practice with that. All right.
I have a question.
Yeah.
Have you gone over any of the new stuff yet? I kind of logged in a little bit later, so I'm not sure if you've gone over any of that or if you will at all.
What do you mean by new stuff?
I mean, like the kind of stuff that we have on our homework and like the kind of stuff that we learned, like not this last time in class, but the time before.
No, nope, I haven't went through that quite yet. So,
okay, cool.
Yep. I do want to switch over though, maybe to this other review really quick, and I want to talk about just so if you're so we just got done talking a little bit about completing the square, and I want to talk about, because this is, you're going to use completing the square to, like if what am I trying to say? So I want you to know how to take something from standard form, which this is, and change it into vertex form. And so if you're going to change to vertex form, right, then you are going to use completing the square to do that. So I'm going to rewrite this as just y instead of h of x, just to make it a little bit more simple there. So y equals x squared plus 7x plus 10. And then remember, when you're changing it to vertex form, you're keeping everything on the same side of the equal sign. When it's set equal to 0, that's when you're solving it, right? Like we did before. So since the leading coefficient on this is 1, then that will be fine for us. And then we can just do y equals x squared plus 7x plus blank, and then we're going to do plus 10 and then minus blank. All right, so we're adding a number in and then we're subtracting it off here. And actually, I'm going to switch this because it's not going to be this hard. This is going to give you weird fractions on this one, so let's just change this to be a 6x instead, just so it's not giving us weird fractions and you're getting lost in what we're supposed to do with those fractions. Okay, so if this was a 6x here, then remember we find half of that middle term, which is 3, and square it, so that gives me 9. So that is what I'm filling in on both of the blanks here. All right, so I get a 9 there and a 9 here, but notice I'm adding 9 there and I'm subtracting 9 there. All right, and so these first 3 terms is my perfect square trinomial. So when I rewrite that, I get y equals x plus 3 all squared. And then I combine these 2 terms together, which gives me 1. Right? And so now that this is in vertex form, I can easily see what the vertex is. So what would my vertex of this parabola be? So we'll always do the opposite of what's inside here, right? Insiders are liars. So that will give us -3 for my x and then +1 for my y. So that would be my vertex, right? But making sure you know how to change it to vertex form is a really important thing on there. Okay. And when it says to change to vertex form, that's when you're keeping everything the same, you know, on the same side of the equal sign. But when it says to solve it, right, that's when we moved stuff over. Did I do that over here? Yeah, right here. Okay. All right, let's look at maybe a few of these to talk about how to, you know, so this time, this 58A, as I'll call it, is in vertex form, and this one's in standard form. But we want to make sure that you know how to find the vertex, the intercepts, and the line of symmetry, right, when it's written either way. So first of all, this one is easy to find the vertex because it's in vertex form, right? So the vertex of that is going to be 3, 3. And then we want to find our intercepts. And so remember, that means that we need to find our x-intercepts and our y-intercepts. So our x-intercept, right, is when you let y equal 0, and make sure you really have this in your head well, which one's which, right? Y equals 0, solve for x. So that means I'm going to have 0 equals -2 x minus 3 all squared plus 3, right? And then I'm trying to solve this for x. So I'm just going to be using that square root property to help me solve it, right? So I'm going to start by, whoops, that kind of went weird. I'm going to solve by subtracting the 3 over. And so that will give me -3 equals -2 times x minus 3 all squared. Whoops, why did I put a square root? I'm thinking ahead here. Sorry about that. Right. And now I'll divide by my -2. And so I get 3/2 equals x minus 3 all squared. And now I can take the square root of both sides. And so that will give me square root, I'm going to put my plus or minus, right? The square root of 3/2 equals x minus 3. And now I'm going to add 3 over. So maybe I'll just put it out in front like this so we can see it. So x is this. But that's going to be really hard to tell where on the graph those show up. So I would encourage you to change those, right, x-intercepts to be decimals so that you can actually figure out where on the graph those would be showing up. So I'm going to just do the 3 plus the square root of 3/2 first. Alright, so I get, on the plus part, I get 4.2. Okay, and then for the other one, so if I do I get 1.8, say. Alright, and then to find the y-intercept, alright, maybe I'll do this in a different color so it doesn't get so blended in there. Alright, so to do the y-intercept, I'm going to let x equal 0 and solve for y. So now I have y equals -2 times 0 minus 3 all squared plus 3. So you don't need to, do anything with this. You can just put the 0 right in there and then just, and then simplify it from here. So we get -2 times -3 squared. All right, -3 all squared is going to be +9, and then +3. So I get -18 plus 3, which is -15. All right, so that really means my ordered pair on this is 0, -15. Okay. And then when I'm looking for my, the line of symmetry or the axis of symmetry that we've talked about, remember that always is going to be, we're going to be looking at the x coordinate of the vertex because it goes right through the vertex. So my axis of symmetry, okay, or line of symmetry, as they're calling it here, is just going to be the line x equals 3. So that's what we're looking at there. All right, now we have all these different parts, so now we can get these plotted on here. So let's try, so if I have, let's see, if we're going to have to go to 15, it just might just have to go down a ways on this, or we can move by 2s. So 2, 4, 6, 8, 10, 12, 14, and so then 15 would be about here. Right. And then if I have my vertex, that's 3, 3. So I'm going to go over, let's see, I'm just going to count by 1s on this axis, it'll be fine. So if I go over 3, and then up 3, well, this was 2, and so it's going to be about halfway in between there. Right, and then my x-intercepts, so at 4.2, so that'll be a little bit past 4, and then 1.8, so it'll be here. I'll use a different color to kind of put it all together. So here's my vertex, and it's going down through that, and then going down through our y-intercept, and then over like this. Okay. And then my axis of symmetry, I said, is this line x equals 3. Okay. Looks like a very strange arrow. Okay, and then you want to make sure that you know how to do the same thing if it's in standard form, right? And if it's in standard form, you want to make sure that you remember that formula for the vertex, right? I mean, you could change this to vertex form like we talked about. If you feel comfortable in doing that, then I'd say you could do that. That's great. But if you want to use the vertex formula, right, remember that's where we said, okay, x is going to be -b over 2a. And then to find y, you're going to plug x into the, just like say plug x in, right? Maybe into the formula. So to do that. So to find this one, right, to find our vertex, our x is going to be -b, so +4 over 2a, so 2 times 2, which is 4. And so my x coordinate of my vertex is going to be 1. And then I need to plug 1 in place of x to figure out what my y is. So y equals 2 times 1 squared minus 4 times 1 minus 1. And then I get 2 minus 4 minus 1. So -2 minus 1, so that -3. And so then there's my point on that one. So here's my vertex. That's one of the things I want. And then to find the x-intercepts, remember we can either try and factor it and see if it factors. If it doesn't factor, then you're going to have to use the quadratic formula on there. So so when we're looking at this, it looks like we will have to use the quadratic formula to do this one, to figure out what those are on this. But let's go ahead and do the Y-intercept, because sometimes you can kind of figure things out a little bit when you do that. And our Y-intercept, remember, is just, if you put x equal to 0, solve for y, so we're really just left with that. So our Y-intercept is going to be 0, -1. All right, so if I put these 2 points in at least, so over 0, down 1, and over 1, down 3. All right, so there's my vertex, and so then I can see, you know, kind of the shape of this and how it's going. I know it's a right side up parabola because it's positive, so I can tell the shape of it's going to be something like this. But like I said, you'll have to use like the quadratic formula or something to figure out where it's actually going to cross the x-axis, which will probably be about here and here, but you will need to find those. But like I said, I mean, like on the test, you're not going to like make everything as maybe as hard as it is here, because we know you have a limited amount of time. So more often than not on something like this, it might, you know, give you something that factors easily so that you can find those x-intercepts easily. Okay, but make sure you do know how to do the quadratic formula just in case. Okay, but it would look something like that, and then again our line of symmetry is going to be at x equals 1. Okay. All right, let me see here. I want to do that one. There's just a lot to go through, right? All right, so let's keep going here, because this is a good one to look at too for the final exam. So an object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. The height h in feet of the object after t seconds is given by that formula, right, by that equation. So how long after the object is thrown will it be 100 feet from the ground? All right, so remember, you got to make sure you're noticing what things are in here, right? So h is the feet, and then t is the seconds. So we're given, right here it's saying that h equals 100, right? So when h is 100, right, how long or how many seconds is that going to take? Right, so let's go ahead and put 100 in place of our h. So that gives us 100 equals -16 t squared plus 12t plus 200. And then in order to solve this, we're going to need to subtract the 100 over. Right, and then so that you'll have it equal to 0, which is what we want, so that we can solve for our t here. And I would say from here it would probably be a good idea just to put it into the quadratic formula. You know, I mean, if you think that you can find a way to factor it, you could try that, but on something like this, it's probably going to be best to do that. So I'm just gonna want to spend time on some of the other things I think you can put into the quadratic formula. Okay. To find x. Okay, and so that's what, or sorry, t. We're finding t, not x on this one. Okay. All right, and then what about part B? When will the object hit the ground? All right, so again, this is telling you something, and it's telling you something about the height of it, right? So when it says when will it hit the ground, we want to know when will h equal 0, right? So again, this time you're going to still put it in, so put 0 in place of your h, and then solve it from here, right? And again, you could go ahead and put that into the quadratic formula. I mean, you could try and factor things out and see if you could, you know, factor it instead. But like I said, I mean, putting it into the quadratic formula is a good way to get there. Okay? And then the maximum height, remember when it's asking you about maximum or minimum of something, the maximum of a parabola, just like we had on this one, this upside down parabola up here, right? The maximum part is that vertex. So it's just asking us to find the vertex of this. So to find the vertex, all right, we'll do, so x is going to be negative b over 2a. So I'm going to have negative 12 over negative 32. Right. And then we'd want to simplify that. So let's see, and simplify that to 3/8, because 4 will divide into both of those, and a negative divided by a negative is a positive. All right, so 3/8 will be my x, and you could change it to a decimal instead. I don't mind either way. And then y equals, and now you're just going to plug that in, right? So negative 16 times 3/8 squared plus 12 times 3/8 plus 200. Right? I'm kind of surprised how many crazy fractions they have given you on this, on this review. So anyway, and so then you can just figure that out, put it into your calculator, and figure out what that would be on there. I don't have a great calculator here. Alyssa, do you have that figured out or no?
No, not quite.
Okay. Alright, so I got it as 202.25. So 202 1/4 is what I got there. Right, so again, don't worry about all of these fractions on here. I didn't realize that they were doing so many things with fractions on here. They really are not going to be as difficult as that, okay? With all of those. Not that those are difficult, but they're just more time consuming, I guess, when you're dealing with a timed test. So that's why it wouldn't be like that. All right, let's look at just maybe these composition functions, just to remember how to do this, right? This is saying put your g function into your f function, so that means you're going to put all of this, right, in place of x in your other function. So that gives us 2x plus 1 all squared, which means it's multiplied by itself. Right? And so then you would just need to FOIL that out to get this. So I get a 2x plus another 2x, so it'll give me a 4x in the middle, and then plus 1. Okay? So that would be what we want there. But however, on this one, notice it's saying put a number into f, and then take that answer and put it into g. Right? So we're putting 4 into our f equation first. So 4 times 4 gives me 16, and then I'm taking that 16 and putting it in place of x in my other one. So 16 goes in here, so we have 16 squared plus 1, and 16 times 16 we got 4096 plus 1, so 4097. That is not right. Hold on a second. Yeah, I was like, that is not correct. I don't know what my calculator had in there, but it was, so 256 plus 1, so that will be 257. Okay. All right, and then to find the inverse of a function, I'm actually going to wait and look at some of the inverse ones that we did on the other, on our other review. And so I'll skip through maybe some of these and look at some of those on the other review. But let's look through this one. If we're graphing exponential functions, right, I just want you to remember that you can always do, make a little chart. And when you're graphing exponentials, you're picking the x's and then you're finding the y's. All right, when you're graphing logs, you're picking the y's and finding the x's. Right? But on this one, so we might want to pick, some numbers like, I'm just going to do -1, 0, and 1, and then we'll kind of go from there. All right? So if I put -1 in place of x, 2 to the -1 power is 1/2, and then 1/2 minus 1 is -1/2. Okay, and then if I put 0 in there, 2 to the 0 power is 1, minus 1 is 0. And then if I put 1 in, 2 to the first power is 2, minus 1 is 1. And then let's do another one. What if I put 2 in? So 2 to the second power is 4, minus 1 is 3. Let's plot these on here and see what we get. So over -1, down 1/2, and then 0, 0, 1, 1, over 2, up 3. This is hard to see. You can kind of tell what's happening here. It's going, oh my goodness. Let me see if I can make that look a little better. So remember, there's going to be an asymptote that it is getting closer and closer to here, right? And most of the ones that we talked about in class were getting closer and closer to like the y-axis. But can you see on this one, it's actually not going to be the y-axis that it's getting closer and closer to. And if you put more negative numbers in, you might be able to see a little bit better of what it's getting closer to, right? If I put in -2, well, that's -4, or -1/4 minus 1, and so that's going to be like 0.75, right? But so it's getting closer and closer to 1. So 1 is going to be where our asymptote is on this. So when it says to graph the function and then put in the asymptote, make sure you remember to see which, where is it getting closer and closer to. Okay. All right, let's look at one underneath it here. So what about solving these when we have exponentials? So we have 4 to the something power equals 16 to the something power. And so we said if we can get the bases to be the same, then we can put the exponents equal to each other. So that would be doable on this one. So 4 to the 3x minus 6 power equals, well, 16 is the same thing as 4 to the second power, and then we'll times that by the 2x that was already there. Right? And now that my bases are the same, they're both 4s, then I can put the exponents equal to each other. So I have 3x minus 6 equals, and 2 times 2x is my 4x. And then I'm just solving for x from there. And so x is -6 on this one. All right, so if you can get those bases to be the same, that's going to be a great way to go about it. Remember, if you can't get them to be the same, then you're going to be taking the log of it. okay, to do that. All right, I'm going to skip graphing the logs, but I do want to end this review with just solving the log functions. So remember, when we're solving log functions, we're going to take our base, raise it to that power, and put it equal to that argument, the stuff that's inside the parentheses there. So 2 to the 5th power equals 3x plus 1, and 2 to the 5th power is 32. And so then I'll subtract the 1 over, and I get 31 equals 3x, and then I need to divide by 3. So x equals 31/3. That's what I'm left with on this one. Okay. And then remember, if it doesn't show what the base is there, that's base 10. So here we do 10 to the 2nd power equals that 5x minus 3. Okay. All right, I want to look at a few off of the review. I mean, we did some of these types of problems already on the review that we just did. So obviously I'm not going to go through all of them again, but there's a few on here that I want to make sure that we go through. And so let's see, I'm going to start on this. So we did some already with the exponents, so I think I'm going to skip over those. Let's see here. So this is the review from the first test that we had there. Okay, I wanted to look at this one first. So let's do number 9 on the, so this was the review that I gave you when you were getting ready for your exam number 1. And so I just again want to make sure that you're, remembering domain and range, and more specifically, like E and F. So I'm just going to kind of do these here. All right, so the domain, you're looking at it from left to right, and these have endpoints. These don't have arrows that take it any further. So my domain, the furthest to the left is -7, and it includes -7. So I will have a bracket there. And then going to the right, the furthest that it is 6, but it doesn't include 6, so that's going to be a parenthesis. And then remember, the range is from bottom to top, so the lowest down is -5, right? And it doesn't include it, so it's an open bracket, and then it goes up to +3. And that one it does include, because it's actually, the line there. Okay. And then if it says, what is f of 5, right? So again, remember, this is saying when x equals 5, what is y? Right? So if we look at x equals 5, so go over 5, and then we figure out where on the graph is that. Well, it looks like here, and we're just going to approximate that a little bit here. And so that looks like that's going to be about -2, right? So I'm just going to say y is approximately -2. Right? Or maybe you could say, like, it looks a little bit lower than that, so maybe 2.1. Right? So it just isn't very exact on that picture. But then what about the other way, right? This one says y equals -2. What is x? Right? So if y is -2, so on the y-axis I'll go over to -2, and then notice there's 2 different places that this shows up, right? I've got one there and one there that I need to look at. And so it looks like my x could be about -7, and x is about I don't know, a little bit less than 5, I guess, on that. So I'm just going to say like 4.8. Okay. The graph should be a little bit more precise than this on the final exam though, but if you need to, you can kind of approximate it if you're looking at it going, it doesn't look like it's quite on a number there. Then, I mean, I will take that into account when I'm grading it. Okay. Let's skip down to, I want to make sure I have time to do some of these other ones. We talked about these last time with the finding the equations of lines. I would suggest that you go back through and make sure you know these really well, right? So if you're given 2 points, you got to find the slope and then write the equation of a line. And then also remember if it tells you, you know, slope is parallel or perpendicular to a line that is given, right? So parallel lines have the same slope and perpendicular lines have opposite reciprocals. So I would suggest that you go back through that and do like parts of number 17 there. Also, if you've had struggles with writing equations of lines. Okay. All right, next thing I want to look at, I'm sorry, I'm just kind of flipping through some of these kind of quick here, but I want to talk about some of these. Let's see. Oh, that's fun. So again, yeah, so there's just more graphing. We did some of this graphing on the other one, but make sure that you remember to do all of these things, right? Find where the asymptote is, the x-intercepts, and then make sure you know how to tell the domain and range of those also. Okay. And again, you have the answer keys to all of these as well, right, that I gave you before. But okay, so I want to look at some story problems because we haven't done a lot with those, and I want to make sure that we spend some time with some more of these and being able to tell the difference between when you're going to be doing what kind of equation. So remember when we're using the y equals mx plus b, right, that this is linear and this has a constant rate of change. Right, so we have to, be able to say that, okay, there's, it's constantly, moving at the same rate all the time. Where on this one, notice that what we're dealing with is a percent change. And so whenever we're dealing with this percent change, then we're actually dealing with exponentials. Right, so we have the y equals a times b to the x power, where a is your start amount and b is your percent change. And so you can use that to really find any, be able to write any of these story problems in that form. Okay. So first of all, let's just kind of read through that and just make sure that we know what we're looking at here, right? So it says in a bottle of sunscreen, it tells you to apply every 2 to 4 hours because its effectiveness diminishes over time. Okay, suppose the SPF of a sunscreen is 50 at the time of application. Every hour the effectiveness drops by 30%, right? The next hour. So when we're trying to figure out what that percent change is, right, then we're saying, okay, they're going to be starting off, at 100%, but then it's dropping by 30%. And so it's really, the effectiveness is staying at 70%. So first of all, just making sure you see where that percent change is coming from, right? So at time 0, right, so we said, so like even before this, right, so at time 0, it's going to be 50, right? But after 1 hour, right, then it's decreasing, right, by 30%, or it's leaving 70%. So you're really taking that 50 and timesing it by the 0.7. Right? And when you do that, that gives you 35. So it's like, so after an hour, it's pretty much like you have an SPF of 35 on now instead of 50. And then after 2 hours, right, we'll do that again. We'll times the 35 by the 0.07, and that gives us about 25. Right? So when we do that, we're like, okay, so that's how much we have over those different amount of times. Okay, so here it just wants us to write a function, right? So using this up here, and so in place of y, we're going to put our s of x, right, where x is the number of hours, right? And so our start amount was 50, right, time of application, so we have 50 times, and then our percent change, remember, is what we put in place of our b, which we said was 70%, so let's put 0.7, 0.7, right, all to the x power. So there we have our equation. So now we could figure out, you know, after, you know, 5 hours, would we have any, you know, remaining on us? And probably not, since it tells you that you should really apply, you know, every 4 hours at the most. But this x gives us a way to figure out which, you know, which hour, how much SPF will be really left on us, right? Okay, and so then this is saying, what would the SPF value be after 8 hours, right? So let's see what that would be. So this is really our x, right? As we said, x hours, right? X is our number of hours, so if I put that in there, 50 times 0.7 raised to the 8th power. Right. Let's see, I'm just going to write it as y equals like this. And then we'll just put that into the calculator to figure out what that is. And so I get like 2.8 or 2.9, right? And so that's like an SPF of 2.9, which is basically nothing, right? Anything, you know, that low is not really protecting you at all, but there's still some, you know, residual left on there. And then this, I'm not going to spend time on figuring out this other one, but this is just saying, okay, another one that you can figure out that models the situation, and so you can just kind of make sure that you know how to rewrite these in the different ways. Okay. All right, let me skip down. And we did some like this already on the other one. I would say it would be a good idea to maybe, you know, practice these a little bit more also if you don't remember very much about these composition functions and how to put those in. There's a few more problems there that you can practice with. And let's see, let's keep going down here. All right, so if we look at this, so it says to tell whether these are invertible or not, right? Meaning, can we find the inverse of these or not? And we said if something is invertible, it means it's a one-to-one function. So this is a linear equation, and linear equations are always one-to-one because there's only, you know, if we're thinking about, you know, how many x's and y's there are, there's not going to be any of those repeated, the inputs or the outputs. And this one's also linear, right? So these are both invertible. And then let's look at this one. So we're looking at our inputs are on the top and our outputs are on the bottom, right? And again, we don't want any of those to be repeated. So all of our inputs are unique and all of our outputs are unique. So this is invertible. Right? However, over here, let's see, we've got all of our inputs are unique, but we have two outputs that are the same. And so since those are the same, it's not invertible. Okay. But now on 34, it says to find the inverse function of the ones that you could. Well, I want to just focus on C and just remember the steps that you need to take to find the inverse of these, of any function that is invertible. All right, so I'm going to write it up here. So I've got y equals 2x plus 11. All right, and remember my steps for this are I'm going to switch my x and y. So I have x equals 2y plus 11. And then I'm going to solve for y. So that means I'm going to subtract my 11 over. So I've got x minus 11 equals 2y. And then I'll divide by 2. Right? And so I get y equals this. So this is my inverse function. And to show it's an inverse function, we write it as f to the negative 1 power of x equals x minus 11 over 2. And you don't need to separate those out or anything, just like that is great. All right, so make sure you remember those 4 steps that we talked about in finding inverses. Right? Switch the x and y, right? Solve for y, and then change that back to the inverse function. I guess the first step that I didn't say there is I changed my function notation to a y. So do that first, then switch your x and y, solve for y, and then change it back to function notation showing that it's the inverse. Okay? All right. Let's see what I want it to look next. And again, we kind of talked about some of these already on the other one, but I would encourage you to maybe go through some more of these solving log equations and solving exponential equations. Those would be good to go through. We did some of those on the other review though, but that will give you a little bit of time there, or a little few to work through. All right, let's look at this number 42 though. I want to make sure that we're remembering this. So notice that again, we're talking about a percent, right? Percent change in this. And so that means that we are going to be dealing with something exponential. So again, when I'm trying to write out an equation for this, I know I'm going to be using that y equals a times b to the x power. Okay, kind of like we did on that sunscreen one up above. Okay, but this one has us find a few more things. That's why I want to go through this one. So let me just take a minute and see if you can figure out how you would write this, right, as a formula, right? All right, so tells us that the start amount, right, is going to be 200 milligrams because that's how much of the medicine they're going to be taking. So 200 is going to go in place of my A. And then B, right, it's saying that it decays, and so thinking of that decaying, right, decays 24% every hour, then we really need to figure out how much is staying in the body. Right? If this much is leaving the body, then we're really doing 100% minus 24%, which is 76%, right? Or 0.76. So that's what we should have here. And then to the t power. Okay. Okay, so hopefully that's what you were able to get for that one. And then, so part B, right? So the patient needs to maintain at least 50 milligrams of medication in their body until the treatment is complete, right? So they've got to keep a certain amount in just to make sure that the stuff doesn't come back and you get, more sick. So it can fight it off. So, so we're trying to figure out how much time, right? So you're trying to solve for time. How much time after the first dose should the second dose be given? Right? And this says do not estimate with a calculator, but I want you to estimate with a calculator. Okay? Oops, let's see. I'll take off this part. So I want you to estimate it with the calculator. Okay? You don't need to put it in the log form, because I think this way you'll be able to really see what the answer is and if the answer makes sense. When it's in log form, you can't really do that. All right, so we're going to put 50 in place of our d of t. So I'll put 50 equals 200 times 0.76 to the t power. And remember, I'm trying to solve for t, which is an exponent, so I know I'm going to have to use logs in order to solve when my variable is an exponent. But we've got to get that part isolated, so let's divide both sides by 200 first. Right. And then what do we come up with there? We have that. And we expect. Right, so 0.25 equals 0.76 to the t power. All right, and now in order to solve this, I'm going to take the log of both sides. So let me do that in a different color here, make sure. So I'm going to do the log of this and the log of this. And when I do that, now my t can come down out in front and be multiplied by it, which lets me be able to solve it. So let me write it down that way. So I've got log of 0.25 equals t times the log of 0.76. And then to get t by itself, I just need to divide by log of 0.76. Okay, and then you just need to put that in your calculator, and it ends up being about 6 hours. And so I'm going to just kind of put that down here. So t is approximately 6 hours. Right? It was like 6.21 or something. But if you wait until 7 hours to take it, then it's going to be lower than this 50 milligrams, right? So we actually want to make sure we're kind of, rounding, down on this so that we make sure that we get it in our body before it goes below the 50 milligrams. So we'd want to say let's take it about every 6 hours. Okay. And then on 43, remember, I'm not going to do all of this one, because we just did one like it, but when it says it's increasing by 4% each year, remember that that's when you're doing 100% plus the 4%. So you got the 104%, which is really 1.04 when you change it to a decimal, right? So when you write it out, right, here's your start amount, and then this is your percent change. Okay? But I would say work through number 43 also on your own. Make sure that you know how to do, those type as well when it's increasing. sure you're remembering how to do factoring and solving by factoring. Okay. And then also make sure you know, like you can tell if something is linear, exponential, or quadratic by looking at a table of values here, right? So if we look at just a couple of these, it looks like this one's adding 12, adding 14, adding 16. So the first, change on this is not constant. But if we look at our second difference, right, that's adding 2 and adding 2. So when we have the common second difference, then that means it's going to be quadratic. Right. And then make sure you know how to fill in that box, right? So if it was adding 16 there, then we'd be adding 18 to figure out what my next number would be there. Oops. So that would give me 70. Okay. And then remember, if you can tell it's linear if it is adding or subtracting the same amount each time on that first difference. So here we're saying, okay, we're adding 20, we're adding 20. Oh, goodness, what's happening here? Try this again. And so then we can see, I don't know why it's doing this. I did this last time too. The end of it. It's like it's getting tired and it's like, oh, I'm done. All right. I don't know what's going on here. Wowzers. This is pretty crazy. Holy Hannah, I do not understand what's going on here. Why it is doing that. Try and switch to a different. All right, kids, I don't know what's going on here, but this is kind of going crazy on me, and I'm not really sure why it is doing this. Okay. I think it may have started working again. I don't know what is going on here. like I said, it did this at the end of last time too, which I'm not really sure why, but all right, so if we're taking a look at maybe some of these other things that we talked about kind of before, right? Being able to simplify the square roots, and we did some of those on the other review too, so I think that's good. And the completing the square is good on that. We talked about those, but I would say please make sure you try those again if you're like, ooh, I really struggle with solving by completing the square. I mean, I will tell you that, I mean, on the test, besides having to write something in vertex form, like on this one, you know, you will need to make sure you know how to do that. But if you're solving something, I don't care if you solve it by factoring, by completing a square, or the quadratic formula. So if you are comfortable with one of those ways, well, things don't always factor, so you need to be comfortable at least with completing the square or the quadratic formula. So, all right, well, let's look at things here. So you're not going to be tested on anything from Module 11 because we didn't cover that, so don't worry about that. Right, but let's do maybe a few more things. I know that I was a little bit rushed in doing some of these, so I want to make sure that you're feeling okay about what we did in the 12, right, in Module 12. So let's look at if we're doing like the fourth root of something like this. So remember that you're going to take the whole number out in front, and you're going to, maybe it's not going to let me. Try something else here. Alright, well, maybe I'll just have to do something like this. I'm so confused why this is not cooperating here. Thought we were in business, but maybe not. Okay. Alright, so I'm just going to try and, I reopened it, hopefully. Sorry. So frustrating when there's problems like this. Alright, hopefully you can kind of see that alright, but I don't know if I dare try and write on it again because it was being so temperamental, so I might just right over here instead. Okay. So again, if we're looking at some of these things, let's actually look at maybe let's look at part D on this one here. So if I have that, so if I have x squared y to the negative 1/2 over x to the 1/2 y to the 3/4, and then the bottom is all squared, right? Then that means I need to distribute that 2 to everybody on the bottom. So let's just leave the top the same. So x squared y to the negative 1/2, and then if I multiply 1/2 times 2, that just gives me 1, so x to the first power. And then here, when I do 3/4 times 2, right, that's like saying 3/4 times 2 over 1, so that will give me 6/4, which reduces to 3/2. So I get, whoops, feeling all flustered now, all of these problems with the technology. Okay, so we get y to the 3/2 power. And then we can see up here that we've got a negative exponent, and so it wants to go downstairs, right? And so when we have that, we'll have x squared over x, y to the 3/2, and then times y to the 1/2. Right, now it's downstairs, and so now we can add those y's together, and we can subtract the x's to find our final answer there. So there's more x's on top than on bottom, so there's one more x on top. And then here, when we combine these together, 3/2, right, plus 1/2 is 4/2, which is really just 2. So we get y to the second power on the bottom. So x over y squared is what we would get there. Okay, so practice a few more of those. Make sure you're feeling confident with those properties of exponents that have the fractions with them. Okay, but let's look at that. We did quite a few of these type of solving different types of equations, right? And so I want to make sure that we're, feeling good about this. So we'll do just a couple of these. So if we look at, let's do part A, and 5 minus the square root of x minus 3 equals 3. So the first thing that we need to do is get this square root by itself, so let's subtract 5 over. Right, and so notice that negative is still there, so be mindful of that. Right, so I get this equals -2, but the square root still is not by itself yet, because really there's kind of like a little invisible 1 there, right? Or I should say -1 there, that is what we need to divide by to get that square root by itself. So we've got the square root of x minus 3 equals 2, and then to undo square rooting something, we square both sides. Right, so we square both sides, get this, and so that crosses out. We're left with x minus 3 equals 4, and then we'll add the 3 over to the other side, so x equals 7. Okay. So make sure you know how to solve equations that have square roots in them, like that. And then let's maybe look at some with, let's look at one with log and one with an exponential. Okay. So let's do d. So log base 5 of x plus 4 minus 3 equals 1. So again, just like we did on the one before, we've got to get, the part that we're trying to solve for by itself. So I've got to get this log part by itself. So I'm going to add 3 over to the other side, which gives me log base 5 of x plus 4 equals 4. And now to solve this, remember I want to change it to exponential form. That's going to be the easiest way. So 5 to the 4th power equals this. Right. So we've got, so that's 5 to the 4th power. Write it down here. 5 to the 4th power equals x plus 4. So 5 to the 4th power is 625. And then to get x by itself, let's subtract the 4 over. So x is going to equal 621. Okay, so remember how to do some of those log ones, and then let's do one with exponentials also. Make sure that you remember how to do some of those. Let's do h. Okay, so h says 4, and then times 5 to the x power minus 3 equals 25. Right, so again, we've got this 4 out in front, and we have this minus 3. All right, so this 4 is connected by multiply, and this 3 is connected by subtraction. So we want to move that 3 over first. So let's add the 3 over. So we get 4 times 5 to the x power equals 28. And now to get rid of that 4, let's divide by 4 on both sides. So 5 to the x power equals 7. And then this is where you cannot get these bases to be the same. And so in order to try and solve these, you're going to have to take the log of both sides. Right? So we'll do the log of both of these. So log of 5 to the x equals log of 7. And now this x can actually go out in front, right, and be multiplied there. So we want to put that out in front. So we've got x times log of 5 equals log of 7. And then to get x by itself, we're going to divide by log of 5. And then you can just put that part in your calculator, and or it might just say to leave it in the exact form because it's not a story problem. But if we do it if we round this to, say, the nearest tenth, we've got, so log of 7 divided by log of 5 equals about 1.2 would be my approximation. Okay. Alright. Trying to think. Maybe let's do one more of these type. I really want to make sure it's, I don't know. Can't tell what exactly you guys want to go over. What's going to be like the most important things like that you're struggling with. So I'm not really sure exactly where to focus on some of these. But is there anything in the homework that you want to look at that maybe wasn't also clear? You want to make sure that we go over. And maybe some of you could just, after you watch this, you could reach out to me and let me know if there's some things that you still would like some more help on, because I'd be more than happy to make another video that has, a few more things on it that maybe I missed on here that you wanted to go over. So I think we'll just end it there today, and then you guys can just email me and let me know if there's something more that I can help you work through, or message me with any questions that you might have. Okay, remember that the test is going to be Wednesday, and it's going to be in our classroom. It starts an hour earlier than normal, so it starts at 9:10, right? So 9:10 a.m. and goes to 11:10 a.m. And there'll be 25 questions on the test, and you have the 2 hours to get those completed. Make sure you bring your scientific calculator that you have been using, that you're used to. I will definitely have mine in class in case you don't have one to use, but I would encourage you to use one that you know how to use the best. Okay? But reach out to me if you have any other questions. Thanks, guys. Have a great day.